What if the thing people online call a weather machine actually teaches you something genuinely useful about the technology running your life right now? Not useful in a fun fact at dinner kind of way, useful in a I could actually build something like this kind of way. Because here's what nobody tells you when you start trying to learn electronics or IoT or wireless tech. The gap between a beginner hobby project on your desk and a massive signal installation in the middle of Alaska is not complexity, it's just scale. The core idea, identical. And by the end of this video, you're going to understand why that's true, and more importantly, what to actually do with that information. Here's exactly what we're covering today. First, what signals actually are, not the textbook definition, the thing that actually makes it click. Second, why you're already living inside IoT, whether you realize it or not. Third, the mental model that most beginners are never taught and why it's the reason most people quit. And fourth, your actual first step, not go watch more videos, a real step. Now, before we get there, I want to come back to HAARP in a few minutes because once you understand the foundation, something about it is going to surprise you. Keep that in the back of your mind. Let's go. Okay, if you've ever tried to learn electronics or wireless tech and felt completely lost within 20 minutes, it's not because you're bad at this, it's because almost every tutorial skips the most important step. They start with the how before you understand the what. They say, okay, here's a resistor, here's Ohm's law, here's a circuit diagram, and your brain does this thing where it tries to file that information somewhere, but there's no folder for it yet, nothing to attach that to. So here's the folder. Technology is just systems sending and receiving information. That's basically the whole game. Your phone, your Wi-Fi, a pacemaker, a Mars rover, a military radar installation, they all do one thing. Something sends, something receives, something interprets. That's it. Once that folder exists in your brain, everything else starts filing itself. The reason I'm telling you this first, before anything technical, is because most people who give up on learning electronics don't give up because it's too hard. They gave up because nothing felt connected. Now it should. Okay, quick question. What did you do in the first 10 minutes of your day today? Because I'll tell you what I did, and I'm willing to bet yours looked pretty similar. I woke up, my phone screen lit up automatically, ambient light sensor talking to the display processor, signal sent, signal received. I turned on my Bluetooth speaker, my phone said, hey, I know you, and they paired in under 2 seconds. Handshake protocol, signal sent, signal received. I walked into the kitchen, the smart plug turned the coffee maker on. Because my phone's location crossed a geofence I set up 6 months ago. Signal sent, signal received. I do not have a smart coffee maker because I'm some kind of tech genius. I have one because the chip that makes that possible costs about $3. This is IoT, the Internet of Things, and I know that phrase sounds like something from a 2014 TED Talk. It's genuinely just this, devices talking to each other. And the reason it feels advanced is because we're surrounded by it. When you're inside something, it's hard to see it clearly. But take a step back for a second, and it's just buttons, sensors, radios, and responses, scaled up, repeated everywhere. Now, let's actually demystify this because wireless signal sounds technical. It's not. Here is the simplest version. You push a button, a light turns on. That's a signal. A simple one, but it's a signal. Now, what if there's no wire? The button still sends information, but instead of running through copper, it ripples outward through the air as a wave, a radio wave, an electromagnetic wave. The receiver on the other end is tuned to that specific ripple. When it detects it, it interprets it, and the light turns on. That's Wi-Fi. That's Bluetooth. That's how your key fob unlocks your car from 30 feet away. Different frequencies, different ranges, different power levels. But fundamentally, same idea. Now, here's where it starts to get interesting. The difference between that key fob and, say, a high-frequency research transmitter isn't that one is simple and one is advanced, it's power and frequency range. Higher frequency lets you carry more information. More power lets you send it further. That's it. That's a whole scale of wireless technology from your Apple Watch to a satellite dish. Okay, I told you we'd come back to HAARP. Here it is. HAARP, the High Frequency Active Auroral Research Program, is at its core a high-powered radio transmitter pointed at the upper atmosphere. It transmits signals at specific frequencies to study how the ionosphere responds. Now, is that interesting? Yes. Is it complicated at scale? Absolutely. But the concept, you just learned it. It sends a signal, the atmosphere responds, receivers measure that response. Send, receive, interpret. The reason people call it a weather machine or a mind control device isn't because it's doing something incomprehensible. It's because most people were never given the framework to understand what a signal even is. Now you have that framework. And here's the thing that should actually excite you. The same ESP32 microcontroller that you can buy online for $4 and wire up on a breadboard this weekend, that thing is operating on the same fundamental physics. Different scale, different application, same idea. I want to be honest with you for a second. When I started learning this stuff, I spent probably 3 months confusing myself. Not because the concepts were hard, but because I was trying to learn components before I understood the systems. I was memorizing what a capacitor does before I understood why I even needed one. I was learning coding syntax before I understood what the code was supposed to communicate. It was like trying to learn a language by memorizing grammar rules before I've ever even had a conversation. The mental model that changed everything for me was this. Every project is a conversation. Something has information, something needs it. Your job is to make that conversation happen reliably. That's the whole job. When you think of it that way, every component, every line of code, every circuit has a reason. It's part of the conversation. Here's where I give you something real, not start learning electronics. That's useless advice. Here's the actual path. Step 1, get an ESP32 microcontroller, about $4 to $8 online. This thing has built-in Wi-Fi and Bluetooth. It is genuinely the best starting point for IoT in 2025. Step 2, your first project is one thing talking to another thing. That's it. Light up an LED from your phone, send a temperature reading to your browser. One sender, one receiver. Step 3, when it works, and it will, don't move on immediately, break it. Change a variable, see what happens. Understanding why something breaks teaches you more than any tutorial ever could. The reason most beginners plateau is they stack tutorials without ever experimenting. You don't get confident from watching, you get confident from doing something, even badly. The first moment where something you built works, where a signal you sent gets received, it changes your relationship with the whole subject. It stops feeling like you're trying to understand, it starts feeling like something you're building. Let's close with the 3 things I want you to actually remember. 1. Technology is system sending and receiving information. Every device, every project, every installation is doing exactly that. Once that framework is in place, everything else organizes around it. 2, IoT isn't advanced. It's everywhere. You've been living inside it. Now you can start building inside it. 3, scale is not the same as complexity. A $4 microcontroller and a research-grade transmitter are doing the same thing. That means you're closer to understanding advanced technology than you ever thought. If something in this video finally made a concept click for you, drop "this clicked" in the comments. I actually read those and they mean a lot. Not because the algorithm likes it, because I'm Allison and I like to make electronics make sense.